Number 21, the conversion of starch to glucose is an example of what? A. Esterification, B. Hydrolysis, C. Polymerization, and D. Neutralization. Now, when we are converting from a big molecule to a smaller molecule, it is called hydrolysis. And why is it called hydrolysis? That's because now from starch to glucose, starch is a big molecule, glucose is the simplest molecule. For example, let's say from protein to amino acid. You know that protein is the big one, but amino acid is the smallest bit of these particular proteins. So these processes are called hydrolysis. That's option B. Number 22, which of the following substances is used in the manufacture of glass? Now, glass is made up of, we have sand, then we have limestone, and we have Na2CO3. Now, sand is made up of these three, constituents. Now, our option, we have A, limestone, B, sulfur, C, granite, D, gypsum. Now, our answer is option A, limestone. Number 23, the percentage composition of oxygen in water is approximately what? We want to calculate that inside H2O, this oxygen, what is the constituent? What is the composition in percentage? Now, the first thing that we do, we know that we're talking about water, that's H2O. Let's calculate for H. For H is what? 1. That's the atomic mass of hydrogen is just 1. Then it will now be 1 times 2. That's 1 times 2 because H2 means you're going to multiply 1 by 2. That's what? 2. Now for oxygen is 16. So it's just 16 alone. Then first now find this oxygen. Okay, let's first find the H2O. Then we'll now say 16 plus 2. 16 plus 2, that's 18. So we know that normally the whole of water has 18. The whole of water has this 18. Let us put it here like this. It has 18. Now I want to now see only for oxygen. Then you now take oxygen 16 all over for all the water. So like we're saying oxygen all over H2O times 100 all over 1. This is what we are doing. As if they're asking me for hydrogen, you say hydrogen all over water times 100 all over 1. Simple. So now we're using this formula. That's 16 all over 18 times 100 all over 1. Now if we calculate it, 16 times 100, that is 1600 divided by 18, that is 88.88. But we add approximately, that is 88.9. That's option B. Number 24, which of the following compounds is a strong base? Is a strong base. Now, a strong base means that when it ionizes in water, it will totally and completely to ionize when it's dissolved in water. Now, a strong base, NH4 and OH is a weak base. NaOH is a very strong base, also called caustic soda. Is a very strong base. H2CO3, this one is a weak acid. Then COOH is a weak acid also. This is alkanoic acid, and all alkanoic acids are weak acids. But we're even talking about base. We have no business with our acid. So our answer is option B, NaOH. Number 25, The process of converting alkenes to alkanes is known as what? Now we have seen that earlier. We saw how we converted when we reacted ethene with hydrogen and it gave us ethene, and it is called hydrogenation. Number 26, which of the following can act as both an acid or a base? A. NaOH, B. HCl, C. Water, D. NaCl. And when something is acting as an acid or base, it's called amphoteric. It is amphoteric. So now saying which of this is amphoteric? Now a very good example of an amphoteric compound is water, because water can denote, it can, according to the Bronsted-Lowry acid and base, Bronsted-Lowry acid will tell you that it's one that will donate, while the base is the one that will what? Accept. So, and water can do both of those things. It can accept and it can also donate hydrogen ions. So because of that, water is amphoteric. Number 27, the main ore of iron is what? Now, A, we have galena, B, we have hematite, C, we have bauxite, D, we have calcitrite. Now, galena, this is the ore of lead. Hematite is the ore of iron. Bauxite is the ore of aluminium. Calcitrite is the ore of tin. And here we are being asked for iron. That's option B, hematite. Number 28, which of the following is a greenhouse gas? Now, what is a greenhouse gas? A greenhouse gas, these are gases that they can trap heat. They trap heat. A, we have nitrogen, B, we have oxygen, C, carbon dioxide, D, we have hydrogen. Now, our answer here is CO2, because CO2, it traps heat. Now, for example, if you notice that when you are when you are on the road, when you are in a hold-up, you notice that now the gas that comes out from the engines of cars, from this exhaust, after the combustion of fuel in a car, all this car engine, is CO2 that comes out. Now, when the CO2 comes out, you notice that when you are in an hold-up or when you are in a hold-up for long, you notice that that place will just be so unnecessarily hot. And that's because CO2 traps heat inside it. So that means that the more the CO2 is in the atmosphere, the more hot that particular place is going to be, or the more warm that place will be. So that is why we call them greenhouse gases. Our answer here is option C, carbon dioxide. Number 29, the formula for washing soda is what? Formula for washing soda is what? Okay, A, we have Na2CO3, B, we have Na2CO3 plus 10H2O, NaHCO3, CaCO3, NaOH. Now this is what we call washing soda. Now this one you see NaHCO3, we use this one very well. Charlie bakers, they use it so well. This is our baking soda. Now CaCO3, this is our limestone, that's calcium carbonate. And this one is our caustic soda. So you can see that they put a lot of soda. So they want to identify which one of them is washing soda. So you must know how the washing soda, the formula for washing soda, the formula for baking soda, and for caustic soda, because they can ask you for any of them. They can even mix them together. Our answer is option A. Number 30, which of the following is an example of a redox reaction? Now, what is a redox reaction? This is a reaction where reduction and oxidation occurs. When there is gain of electron, there is loss of electron, there is gain of oxygen, loss of oxygen, gain of hydrogen, loss of hydrogen, depending on the particular reaction. A, we have neutralization, B, we have precipitation. C, we have combustion of methane. D, we have dissolving sugar in water. Now I'm going to tell you your answer, and I'm going to give the reason why that is the answer. Now you look at neutralization. Let's write a neutralization reaction. For example, we have, let's say, HCl plus NaOH. Don't forget that neutralization reactions will give us salt and water. So it's give us NaCl plus H2O. Now if we look at this, there is nothing like redox because oxygen is not leaving on. Oxygen is not leaving. There is no loss or gain of electron in this particular reaction. When we look at this combustion of methane, let's write time. Now, what is combustion of methane? This is when methane burns in the presence of oxygen to give us CO2 and water. Now, let's say CH4 plus O2, that will give us H2O plus CO2. Now let's see if our equation is balanced. H here is 4, H here is 2. So if you put it here, our equation will be that's 2 plus 2. Put 2 here also. CO4, H4. So it's balanced like this. Now, if you look at it, from this CH4, now something will happen to this CH4 when it got to this place. What happened? It had hydrogen, but instead it now added oxygen. Now what happened here is that this one was oxidized, and this O2, it's when hydrogen added to it, and when the addition of hydrogen is called reduction, while oxygen was reduced. So that means that this particular combustion of methane is a redox reaction. Number 31, the hybridization of carbon in ethene is what? Now note that in alkanes, the hybridization of alkanes is sp3. In alkenes, it is sp2. And in alkynes, it is sp. That is the hybridization. So when you say ethene, ethene has the suffix ene. That means we're talking about the alkanes, and that is sp2, option B. Number 33, which of the following salts undergoes hydrolysis in water? Now, what is hydrolysis in water? It means that which of these will dissolve in water and produce hydrogen ions. Now we're talking about which one will dissolve and give more of these H plus ions. That means which of these will dissolve in water to be very acidic. Now here we have NaCl. Now when NaCl dissolves in water, it will give us NaCl. Okay, NaCl, we have KNO3, we have NH4Cl, and we have Na2SO4. Now when this one will dissolve in water, it will give us NaOH and HCl. This one will give us KOH and HNO3. This one will give us NH4OH plus to give and HCl. This one will give us NaOH and H2SO4. Now, since we know that this is what these ones will give us, now let's know that the resulting solution will be acidic. If you look at NaCl, this NaOH and HCl, if you notice that they are both strong acids. This is a strong base, strong acid, so it will be completely ionized. There is no hydrolysis that will happen. Now for KNO3, strong and strong, nothing can happen. The resulting solution is not acidic. For NH4 and HCl, NH4OH is a weak base and HCl is a strong acid. Because of that, HCl will overpower NH4OH and it will now give us hydrolysis. So we can see that this is our answer. Now Na2SO4, NaOH and H2SO4, they are both strong. So our answer here is option C, NH4Cl. And sometimes the question can come is that which of these following will be acidic? So these are the way these kind of questions come out. Number 33, the gas produced at the anode during the electrolysis of conch brine is what? Brine is just water that they have added in NaCl2. That's what they call brine. Now, at the cathode of this reaction, what will be released, or the gas that will be produced, will be the hydrogen gas. While at the anode, the gas that will be produced is the chlorine gas. And they're asking us for the anode, so our answer here is option C, chlorine. Number 34, which of the following has the highest electronegativity? Now notice that the most electronegative elements are the halogens. The halogens are the most electronegative elements. Now we have the most electronegative element is now the first member of this group 7, these halogens, and that is now fluorine. Fluorine is a very strong, it is the most electronegative element we have on the periodic table, while the most positive is potassium. Number 35, the process of heating coal in the absence of air is called what? Now when you heat air in the absence of air, is called, when you heat coal in the absence of air, is called destructive distillation of coal. And you have things like coke, you have things like ammoniacal liquor, you have things like coal tar, and so on and so forth. So this is what we have: ammoniacal liquor, these are things that you have when you eat your coal in the absence of air. Number 36, a solution contains 0.5 moles of NaOH in 250 cm cube. Its concentration is what? Now the formula for, in fact, with the answer, you should know the formula you are going to use already. We are going to use concentration is equals to, we have mole over volume. Why? Because in our answer, they gave us a mole per dm cube. And though in physics, they will tell you that it is mole all over dm cube. This minus means that it is all over. So you can know the equation that you use from the unit of your answers. Now, but if you notice, this one here is in dm cube, but here is in cm cube. So we need to do something about that. Now, to convert from cm cube to dm cube, we divide by 1000. So that would be 250 divided by 1000. That is 0.25. That's going to be 0.5 all over 0.25. That will give us 2 mole per dm cube. That is option C. Number 37, which of the following substances will give a silver mirror with Tolin's reagent? Now this particular statement is a test. They use it to test for some things, and they use it to test for alkanals, or we say aldehyde. It's test for aldehyde, or you can say alkanal. Now if you are testing, when you test for aldehydes or alkanals, it gives a silver mirror with Tolin's reagent. So an example of an alkanal here is ethanol. That's option C. Number 38, the shape of ammonia molecules is what? That's ammonia is NH 3. Now, when you see a compound that looks like this and has something like 3 here, just know that automatically the it's going to be a trigonal pyramidal. So answer is going to be option C. For linear, example of linear molecules, we have CO2, we have SO2. When you see O2, it is likely, not that it is always, but it is likely to be linear. Now, tetrahedral, when you see something that ends with 4, don't forget that tetra means what? It means 4. For example, CH4, that's methane, it is tetrahedral. Now, bent, a very good example of a bent molecule is water, H2O. So these are some things that you should know, that they always repeat this pattern of questions when you're talking about shape of molecules. Number 39, which of the following processes is endothermic? What does endothermic means? It means that it will absorb heat, while exothermic will liberate heat. A. Neutralization, B. Combustion, C. Thermal decomposition of CaCO3, D. Respiration. Now, answer here is option C, the thermal decomposition of CaCO3. Why? This one is exothermic. Heat is always will be released. Now, combustion even has to do with heat directly, so it is exothermic. For this thermal decomposition of CaCO3 to give, that is CaCO3, it will decompose to give CaO plus CO2. Now, this particular one is a very good example of an endothermic reaction, because when it is reacting, if we touch the vessel, it will be cold. Respiration, energy is always released and in form of what? Heat. So it is exothermic. That's option. Our answer is option C. Number 40, the number of atoms present in 1 mole of carbon is what? Now, irrespective of whatever element you are giving here, just know that the number of atoms of 1 mole of any element or compound is equal to the Avogadro's number. So now this question, they're not trying to test if you know what Avogadro's number is. Now, Avogadro's number is 6.02 times 10 raised power 23. That's option C. Our answer is option C. And this brings us to the end of our class. If you have any question, don't hesitate to drop your question in the comment section. And don't forget to subscribe to our channel and ring the notification button to get more videos like this. See you in our next class. Bye.
Hi, I'm sure you enjoyed the video you just watched. To see more content as that, preparing you for your upcoming exam, make sure to smash the subscribe button and turn on notification. Also, remember that you can use the comment section to send us your questions or your inquiries, and we are happy to take them. I'll see you in the next video. Bye.